Welcome back. So in this video, we're going to learn about a very important concept in physics called vectors. And vectors are one of those things that are used from here onwards in all of physics. So it's really important that we get the basics down and understand what they're about. So to start, I wrote here a list of 6 statements, and we're going to see if they all make sense or if there's something weird in them. So the first one says, a velocity of 2 meters per second to the west. If you hear that, you might think, okay, sure, a person was going at 2 meters per second, a speed, and the direction was to the west. That makes sense. Now let's look at the second one. So this one makes sense. The second one says, a mass of 70 kilograms towards the door. Do you think it makes sense at all that someone has a mass in a direction? Just saying 70 kilograms is enough to know a mass. You don't need to say towards where. Actually, it just makes no sense. So this one makes no sense. Then I put a temperature of 37 degrees Celsius to the left. What does a temperature have to do with a direction? Makes no sense at all. A volume of 200 liters towards China. If you have a volume, again, you don't need to express a direction. Then a push downwards with a force of 5 newtons. Does that make sense? Well, of course, if you push a box downwards, it's different than if you push a box to the left, to the right, upwards, right? So this one makes sense. It does give you some useful information to say the direction in which you're pushing. And the last one says a displacement of 6 kilometers towards the mall. That one makes sense as well. It's important to know in what direction you're going when you're moving, when you're displacing somewhere. So towards the mall would be a different displacement than 6 kilometers towards the airport or to the left or west or north, right? So this one makes sense. So why are there 3 statements that make sense and 3 that don't make sense? Well, what we're going to notice here is that in physics there are 2 types of quantities. One of them is called scalar, and the other one is called vector. So these 2 words from the title, scalars versus vectors. So scalars are the ones that make sense without giving a direction. That includes mass, temperature, and volume. And vectors are the ones where direction means something important. It gives you some extra information that is useful to know. So that includes velocity, force, and displacement. So let's write the definitions of these 2 concepts. All of the scalar ones were okay with just the number and the unit. That's a magnitude, right? So scalars have only a magnitude, which is a number and a unit. While vectors have 2 things, a magnitude and a direction. Have a magnitude and direction, so that's a number, a unit, and something that expresses direction. So that means in our list, scalars are when we find the number and the unit, such as 70 kilograms, 37 degrees Celsius, 200 liters. You always need to give the unit as well, not just the number. And in vectors, we need to find a magnitude and a direction. So for example, in velocity, we found 2 meters per second west. In the force, we found 5 newtons downwards. And in displacement, we found 6 kilometers towards the mall. Now I'm going to make a list of the most common scalars and vectors so that we know which ones there are. So things that don't require a direction. We already talked about temperature, mass, volume, area, perimeter, density, energy, time. And I'm going to write 2 that will probably not make sense right now, but I'll explain them in just a minute. So we also have distance and speed. So except for distance and speed, you can take any of these and try to give them a direction, and you'll see yourself that it makes no sense. And now vectors, we have acceleration, force, the concept that you're going to learn next year called momentum. And then we have two that I'll just explain in a second, displacement and velocity. Right, so all of these are quantities that you can put a direction and they'll make sense. So here we see that we have sort of repeated terms, you might say. So we have distance and displacement. Until now, those two had been synonymous. And we also have speed and velocity. Until now, we had used those terms interchangeably, but not anymore. Really important to know the difference from now onwards. So I'm going to explain displacement and distance and then speed and velocity. So the most basic difference between displacement and distance is that distance is a scalar, so it doesn't include a direction, and displacement is a vector. So both are given with the same unit, right? So you can have 5 meters, you can have 20 kilometers, you can have 3 inches, right? Those three would be distances because they don't say the direction. But you can have 5 meters north, you can have 20 kilometers downwards, or you can have 3 inches to the left. So while the top 3 are distances, the bottom 3 are displacements. So how are they defined? Distance is the total length that you covered or traveled. And the displacement is how far from your starting point you end up, including the direction. So let's give an example of this. Suppose you love walking, so you go from your house and you just want to travel around your city or whatever. So first you go east, let's say this is north, south, east, and west, right? So east to the right, north up. So you go east first for 5 kilometers, then you decide to go south just for 3, then you go again east for another 3, then you go south for 5, then you start coming back, so you go 8 to the west, then you go down to the south another 2, and then you go to the west another 5, and then you go north, what's this, 3, 5, 8, 10, and then you go another 5 east, and you come back home. So your distance, to get the distance, you would have to add each of these pieces. So 5 plus 3, 8 plus 3, 11 plus 5, 16, plus 8, 24, 26, 31, 41, 46. So your total walking distance is 46 kilometers. And because it's a scalar, you don't need to give a direction. But your displacement is how far from the starting point you ended up. So you started at your house and you ended at your house as well. So your total displacement, how far you are at the end from your starting point, is actually 0. So anytime that you give a whole circuit and you come back to your starting position, the displacement is going to be 0. But let's say, for example, when you were around the middle of your trip, you were, let's say, here. Right? When you were at that point, what was your distance? Your distance was adding 5 plus 3 plus 3 plus 5, which is 16. So in this other moment, your distance was 16 kilometers, but your displacement is how far from the starting point you ended up. So you started here, and your total displacement would be the straight line distance from the origin to the place where you stopped, right? This arrow would be your displacement. So you would actually have to use mathematics to figure out the displacement, maybe like a triangle and using Pythagoras. I haven't really calculated it, but when we learn how to calculate it, we will. So let's say it's 11 and it's not exactly east nor south, it's southeast. So that's written as SE, right? So because it's a displacement, you always have to give the number, the unit, and the direction. Right? So they're almost always, the distance and the displacement are going to be different. Now let's look at the difference between speed and velocity. So in speed and velocity, the same thing happens as with distance versus displacement in terms of the units that you use. So speed can be 5 kilometers per hour, or it can be 10 meters per second, or it can be 12 miles per hour, right? And velocities have the same unit and can have the same number, but they have a direction as well. So a velocity would be written as 5 kilometers per hour east, or 10 meters per second downwards, right? Or 12 miles per hour south. So the velocity just gives you more information because it says in that specific moment in which direction you were traveling. So suppose you have, for example, a very curved road, like the roads here in Colombia, right? And you have a car, which I'm going to draw just as a little square, right? And you're here, and then later on you're down here, and later on you're here, and later you're here, and then finally here. So that's just the car moving in time. And maybe you keep a constant speed of 100 kilometers per hour. So constant speed is 100 kilometers per hour. So that means that your speed is constant, but not necessarily your velocity. Why? Because since you were going in curves, your direction is constantly changing. So for example, here at the starting point, your direction is almost east. But later when you're down here, even though your speed is still 100 kilometers per hour, your direction is even more south. And later again, you're a little bit more east, and then you're like really southeast, and then you're basically just south, right? So because the direction is changing, you're not going at constant velocity. So not constant velocity. If you have a stone, for example, and it's tied to a string, and it's going around in a circle, you might be making it go around at a constant speed, let's say 5 meters per second, but the direction is constantly changing. At this point, the direction is to the left, but then when the stone is here, the direction will be downwards, and like that. So basically, the difference between speed and velocity is just that velocity includes more information. It includes information on the direction. So if I ask for a speed, you give me a number and a unit, just a magnitude. If I ask for a velocity, you give me the number, the unit, and the direction. And finally, we're going to talk shortly about vector notation. So vectors are usually expressed like an arrow. Why? Because an arrow can give you information about a magnitude and a direction. So if you have an arrow, arrows have two things that are going to help us with this. Arrows have a length, which is going to talk to us about the magnitude of the vector, and they have an angle, which can give us information on the direction. So how does that happen? We can always place the arrow in a Cartesian coordinate plane and see what the angle is with the x-axis. So if I draw that same arrow in this coordinate plane, we're going to have a distance. That is going to be our magnitude, right? So the length is the magnitude, and we're going to write it as v. It's just the magnitude of the vector. And then it's also going to have this angle over here. We call it theta, angle theta, and that's going to give us the direction. So vectors are usually written as whatever the letter is. For example, in velocity, it's v with an arrow on top. The arrow just means that it's a vector. So this would be a velocity vector. And a with an arrow is an acceleration vector. If we have an x with an arrow, that's the displacement vector. And the force vector is usually written as an f with an arrow. So these are the vectors, but we're just going to use v because it means vector. So a vector can be written as the magnitude v at a direction theta. So this is a way of writing a vector. But that's not the only way. We can also notice that if this is in a coordinate plane, we can find its coordinates. So let's say this is 1, 2, 3, 4, 5. And this is 1, 2, and only 3 fit. So we could find the coordinates of the tip of the arrow. So the tip of the arrow has a coordinate x and y, right? In this case, it seems like that is 5 and around 2.5. So we can express that same vector as a coordinate. The coordinate in this case, x goes first, so that's 5, comma, 2.5. Right? Maybe the length of that vector was, let's say, that's about 7. So we can also say it is 7 at, and that angle could have been, I don't know, 40, at 40 degrees. So the same vector can be written as 7 at 40 degrees or 5, comma, 2.5. It's just two ways to write the same vector because it represents the same arrow, the same green arrow here. So this one we call the magnitude and direction notation because it explicitly gives us the magnitude and the direction. And this one we call the components notation. Why? Because the x and y, the coordinates, are called components. So we have two components. Our x, which we usually call vx, is the horizontal component. And our y here, which we call vy, is our vertical component. So if I give you an example of a vector, let's say my vector is 1, comma, -1. If I ask you, what's the horizontal component of this vector? It's 1. And what's the vertical component of this vector? It's -1. If I give you a completely different vector in the other notation, and I say, let's say one of our examples for velocity, 100 kilometers per hour east. And I ask you for the magnitude, you can tell me it's 100 kilometers per hour. If I ask you for the direction, you can say it's east. So whichever form I give you the vector as, you can tell me different information about that. And in the future, we're going to learn about how to pass from one notation to the other.